All right, we've talked about a what are the right triangle or ratios, the trigonometric ratios: sine, cosine, tangent, cosecant, secant, use them. If we're given a triangle, a right triangle, then if we have two pieces of information from two of the side lengths or two of the angles, or one of the side lengths and one of the angles, any two pieces of information, these angle measures, other than just that we know this is a 90-degree angle, then we can solve the whole rest of the triangle using our Pythagorean theorem and our trig ratios. So let's work on that and see if we can get that down. If you have a right triangle, let's say that we know this is 56 degrees, and we will go back and forth between degrees and radians, so make sure you understand how to do both of those. If we know that this angle is 56 degrees and this leg is 11 units long, then we can find what the rest of them are. For example, since we know this is a triangle, there's 180 degrees in a triangle, so we say 180 degrees minus 56 degrees, and that'll give us this angle B right here. Well, and 90 degrees, sorry. So we subtract all those and we get 34 degrees, and that's angle B. So a triangle is 180 degrees, which means a right triangle. We've got a 90-degree angle there. So the other two angles, the acute angles, have to add up to be 90 degrees. So we can find the other angle if we know one of them. Now once we know all these angles, we can use those to find our another leg using trigonometric ratios. For example, we know that this leg is 11 and this angle is 56. This is the adjacent leg to this angle, so we can use our cosine, and that is opposite or adjacent over hypotenuse. So we figure out what the cosine of 56 degrees is, and hopefully this is algebra that we understand. So we get 11 over the cosine of 56 degrees, and you type that into your calculator, and you'll get that C is approximately 19.7. Now, once we have that this leg is 19.7, you can find this one either using a trig ratio or using the Pythagorean theorem. So if you wanted to use the Pythagorean theorem, you would say a squared plus 11 squared equals 19 squared and solve for that. Or we can use trig ratios and say the sine of 56 is opposite over hypotenuse. And it's really better if you leave this in your calculator with all the different, all the decimal places out, so that we can get a more accurate answer. But if you multiply 19.7 times the sine of 56 degrees, then you're going to get A, and that's approximately 16.3. So those are the answers that we get. So we start out with two pieces of information, use the fact that a triangle has 180 degrees in it, and our trig ratios, or you can use Pythagorean theorem, and you can solve the rest of the triangle. Now, that's great, but how does that really help us? Well, we're going to do some word problems. There's a lot of different ways that trig can be used in real-world problems. So we need to be able to solve these right triangles so that we can solve these. Now there's a couple of things that you need to realize. If you have a word problem, then if you have this angle here, this is your line of sight, and this is the horizon, then this is called an angle of elevation. So if a problem says your angle of elevation is 30 degrees, that means that you're looking up 30 degrees above the horizon. Now, if you have an angle like this, and this is the horizon, and this is your line of sight, and you're looking below the horizon, then that's called an angle of depression. And you'll just need those terms so that you can understand what they're asking you. Now, one of the most important things that hints that I can give you for these is to draw a picture. When you're doing these problems, draw you a picture, label all the parts, and then start trying to work through what they're asking. So we're going to work on some problems. I'm just going to read them off to you instead of writing them down because that'll take a long time. So if you need to pause it and replay it, go ahead and do that. So if we have a hiker that leaves camp and walks up a mountain slope at an average angle of elevation of 36 degrees, if the hiker walks at 3.2 kilometers per hour for 45 minutes, what is his elevation above the camp? All right, so let's see what we've got here. We've got this hiker climbing a mountain. And the average angle of elevation, that means above the horizon, is 36 degrees. And they climb, we don't know how far up they've climbed, we haven't figured that out yet. They climb up this distance, and we want to know how far, what the elevation is above the camp. So if the camp is down here, then this is the angle, or the height that we're looking for. That's the one that we want. So we've got to figure out how we can figure this out. Well, what information are we given? We're told that the rate that they're walking is 3.2 kilometers per hour, and the time they do that is 45 minutes. Well, right now you should be having alarm bells going off in your head because we want to find a distance, we know a rate and a time. And that is a formula that you should have learned in about pre-algebra and should have been using a lot since then. So we know that distance equals rate times time, always. So we can find out this distance. Since he walked this distance, and that's the rate and the time, we can use our distance equals rate times time formula to figure out what that is. Now, we have to be careful. We're doing kilometers per hour, hours. So our time needs to be in hours as well. So our hours, if we have 45 minutes, is 3/4 of an hour, right? So we multiply this times 3/4 hours. Notice that the hours divided by hours is 1, so that cancels. We calculate this all out, and we get 2.4 kilometers. So this distance is 2.4 kilometers. Well, now we know two pieces of information, and we can find everything else out about this triangle. But what do we need? Well, we need the opposite of this angle here. So what trig function uses opposite? Right, sine. So we use sine of 36 degrees equals opposite over hypotenuse. Now, this, remember, is just a number. Make sure you're in degree mode, and you can get this just a number. We've got our variable divided by a number, so the opposite of division is multiplication. So we multiply both sides by 2.4. So in our calculator, we type 2.4 times sine of 36 equals, make sure we're in degree mode, and we get 1.412 kilometers equals h. And on these problems, for the most part, I want 3 decimal places. So just keep that in mind. All right, let's try one more example. All right, a light aircraft flying at an elevation of 1 nautical mile, which is 6,076 feet, loses power 3.5 nautical miles from the landing strip. If the glide angle, or the angle of depression, for the aircraft is 15 degrees, can the pilot make it back to the airstrip? Okay, so we're flying along, and we start out 1 nautical mile above of elevation above this. And so here's the airport right here, and this is where we're starting out. And our angle of depression is 15 degrees. Now, from where we are to the airport is 3.5 nautical miles. So what we need to do is figure out what this value is and see if it's at least 3.5 nautical miles, because that's how far we have to get or we won't make it to the airport. Well, we've got 2 pieces of information and we need a third. We've got an opposite, and what we need is the adjacent to this angle that we know. So what uses opposite and adjacent? Tangent does. So we have tangent of 15 degrees equals 1 over x, opposite over adjacent. Now, we rearrange this using our algebra. So x equals 1 over the tangent of 15 degrees, which means that x equals 3.73 nautical miles before we're going to crash into the ground. So, are we going to make it? Yes, because we can go at least 3.5 miles before we will crash into the ground. So at 3.5 miles, they can make a little adjustment and land. So obviously that kind of stuff is important to know. It'd be kind of bad if we crashed into the ground because we couldn't figure out how far we could glide. So, trig functions. If you know 2 pieces of a right triangle, then you can solve all the rest of them using Pythagorean theorem, the fact that the triangle has 180 degrees in it, and trig functions. So make sure you know how to do that, and make sure that you understand how we got the pictures from these word problems, because that is going to be the big thing here, is getting these pictures from the word problems, because once you have the picture set up, then you can see what all you need to do. Make sure you've read this section, taken some notes, looked over all this stuff, written down any questions you have so that we can go over this in class.